everybody. This is my Physics 2212 Lab 1 charged tape. For a table of contents, first we'll be having an introduction. We'll be going over applicable physics principles, my models, experimental and computational, data analysis, conclusions of possible errors, and some questions raised. What is the purpose of this experiment? Well, the purpose is to create an experimental model wherein tape becomes charged and exhibits electric force interactions, and create a corresponding computational model to compare experimental data. These, when accomplished, will demonstrate the following physics principles: Newton's second law, force of gravity, and electric force, or Coulomb's law. So, what are the underlying physics we're playing with today? Well, first is Newton's second law, which states that F net equals 0 when an object is at rest. In this case, tape A and B will be at rest. And so the magnitude of Fg is going to equal Fe because gravity and electricity are operating in opposite directions. And since the object is in motion, then these forces are equal in magnitude. So that brings us to our next force, which is the force of gravity. Force of gravity is an attractive force generated by mass. So near the surface of the Earth, F equals mg. And that will be applying to tape B today, which is our system. And then electric force, or Coulomb's law, electric force is applied by electrically charged molecules. And because we'll be charging the tape, then electric force will apply here. So, the system is going to be tape B. And our surroundings will be tape A and Earth. Tape A will be exhibiting electric force in an upwards direction, or a positive y direction, and Earth will be exhibiting gravity force in a downwards or negative y direction. And a brief preview of findings can be seen here. The force of gravity is equal to negative mg, which is negative 7.742 times 10 to the 15 newtons. You guys remember that from Physics 1. And then electric force, in this case, will just be the opposite with equal magnitude of gravity, thanks to Newton's second law. And the computational model affirms this. Ultimately, we find that the charge on the tape is Q equals 2.782 times 10 to the negative 9 coulombs. And you can see a free body diagram on the right. So for experimental procedure, first we have to charge tape. So we have a piece of base tape laid down, and we put a piece of U-tape over it, and then rip the piece of U-tape off, and that charges the U-tape. To figure out what type of charge the U-tape had, then we created an electrically charged pen by rubbing it through hair. You can do that with any molecule that will allow the pen to pick up electrons. And then we placed the pen near tape, and tape was attracted to it. So we knew then that our tape was positively charged. Then we created an experimental setup where we put a piece of tape, tape B, between two objects, and then another piece of tape, tape A, underneath it. And we held tape A increasingly upward until tape B moved. And that was the distance at which electric force began to operate. And that can be seen in figure 5 in the bottom left. So the D measurement is the distance at which tape A begins to exert effects on tape B. So for experimental calculation, we have some initial conditions. So mass of the pieces of tape is 7.9 times 10 to the negative 6 kilograms. The distance at which tape A started to affect tape B is 0.03 meters. G is 9.8 meters per second squared. That's a constant. And then K is 9 times 10 to the 9 Newton meter squared per coulombs squared, which is also a constant. So we know from our preview what the force of gravity and force of electricity are. And then to solve for the charge of tape, we use the following formula. So we use F electric, and then we use K, which is the same as 1 over 4 pi E0, and then multiply that by Q squared over D squared. And so ultimately, you can see that calculation at the bottom left, and that's how we derive the Q value that was also seen in the preview. This is my computational model to create an on-glow script that reflects the experiment. And you can see relevant things highlighted. So yellow is our force of gravity, pink is our charge calculation, and blue is our force of electricity. And as you can see in the bottom right, ultimately the force of gravity and the electric force are inverses, but they're equal in magnitude. And the charge on the piece of tape was the same as found in the experimental model, which is great. And that answers question 1 from the Lab 1 document. So for some discussion and possible errors, the computational model confirms our experimental results. The forces of gravity and electricity are equal and opposite between the two positively charged pieces of tape. With this knowledge, we used Fg equals mg to determine Fe, and then used Fe and the assumption that both tapes had equal charge to solve for Q, the charge on each piece of tape. So as just stated, this did rely on a few assumptions. So we assumed there were only two forces, electricity and gravity, acting upon the tape. And we also assumed tapes A and B to be equally distributed point charges. So that answers question 2 from the lab document. And then for some possible errors, handling may have returned some electrons to the tape in the process of experimental setup. So the tape became electron poor after ripping it. And if we touch that region, then the tape could take some electrons away from my hand. And so that could have made the tape slightly less positively charged than it would have been otherwise. And then another possible error is that tapes A and B may have had different charges or an uneven distribution of charge across their lengths. So you have to remember we relied on the assumption that tapes A and B were equally distributed point charges and that they were equal. And that might not be the case. So that's another possible source of error. But what are some questions raised? So what if electrons had positive charge and protons had negative charge? Well, if charges were spontaneously inverted, the universe would implode. But in all seriousness, in a hypothetical where electrons are now positive and protons are negative, the interaction seen would not change. Like charges would still repel, So the now negatively charged tape A would still repel tape B, and other charge interactions would be similarly unaffected. Now, of course, if we're going to make protons negatively charged and electrons positively charged, if we're thinking about it from like a physics atom level perspective, it'd be different. But I think in the cases of this experiment, that sufficiently answers it. And then why is it important to handle the charged tapes as little as possible? Well, as mentioned, as a possible source of error, when charged tapes encounter our hands, they take electrons from our hands, balancing the positive charge and effectively reducing its charge's magnitude. So that's my first lab report. I hope you all enjoyed, and I'll see you all in the next one.